Pre-APCalculus, this is Notes 8.4. This is the final video of the section and of the chapter. I asked you to complete this problem on your own, and now you should be checking your answers. What's the equation of the horizontal asymptote? Well, it looks like if we move to the left, these y values are getting closer to 3. So I'm saying the limit of f of x equals 3 as x approaches negative infinity. Therefore, there's a horizontal asymptote of 3. Is the graph of f of x above or below the horizontal asymptote? Well, for f of x, all the y values are less than 3. Therefore, the graph of f of x is below the horizontal asymptote of y equals 3. When you graph the inverse function, will the graph be to the left or right of the vertical asymptote? Explain your reasoning. Well, since this is the inverse, we would say all of the x values are less than 3. So the graph of f inverse is to the left of the vertical asymptote of x equals 3. What's the equation of the vertical asymptote? Of the vertical asymptote of the inverse? Explain your reasoning. Well, for f of x, the horizontal asymptote is y equals 3. Therefore, f inverse is going to have a vertical asymptote of x equals 3. What's the domain and range of the function and its inverse? The domain of every exponential function is negative infinity to infinity. The domain of every logarithmic function is negative infinity to infinity. The range of f of x, this here we're saying that y is less than 3. That means it's going to go from negative infinity to 3, which means the domain for the inverse is going to go from negative infinity to 3. Find the inverse of the function f of x. We interchange x and y. We get the base and the exponent by itself. We change the logarithmic form, and we subtract 2 from both sides, and we get this inverse here. On the grid to the right, sketch this graph. Here's how I sketch this. We took the starting point of 1, 0, which would be, right here. Hold on a second. Should be right here. And then we have to flip this over the vertical asymptote. That's what this negative here does. That puts this point over here at negative 1, 0. Then we have to move it to the right 3 and down 2. If we move that point to the right 3, 1, 2, 3, and down 2, that puts us right down here. So this is the starting point. From there, since our base is 2, we would normally be going, up 1 and to the right double that, which would be 2. But since this has a horizontal reflection, as we move up, we're going to go left. So we went left 1, then we go up 1 and left 2. Up 1, 2 times 2 is 4. Up 1, double 4 is 8. That's how we get those points. Moving to the right, the distance is cut in half. 8, 4, 2, 1, a half, a fourth, and an eighth, a 16th, etc. That concludes the notes in the chapter. Please do the homework that goes with section